People, good evening and welcome back again to the channel. Hope all of you doing great, having a good time. Quickly, let me know in the chats if all of you can hear me, if I am perfectly audible and visible to every one of you. Quickly, let me know in the chats with some fire emoji. All of you can hear me if I'm perfectly audible and visible to every. Welcome back, people. Let me know quickly in the chat. Let me know quickly in the chats if all of you can hear me, if I'm perfectly audible with the fire emoji. Everyone. I believe I am. So, my dear students, as you all must be knowing, we are done with the part one of the Molar. As I told you in the last session, we are going to do all the chapters in the detailed format, all the theory, all the problem patterns, every single thing shall be detailed. So that's the reason why I have dedicated some 3 to 4 sessions for this particular. You know, this chapter, it forms the basis of your. This chapter is strong, your entire chemistry. If there is a problem in this particular chapter, that means there will be problem in the entire chemistry. Oh my God, I forgot to take down the mic. Is the voice clear now? Is it clear? Is it clear? Is it clear now? Is it clear? Quickly. Yeah, is it all clear? Now I think it's fine, yeah? Hello, 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 hello. Just let me check it. Hello, hello, hello. Yes, I think yes, it's fine now. It is fine now. It's fine now. Yes. Perfect, guys. So let me know once in the chats, first of all, how many of you watched the first part of this particular chapter? How many of you watched the first part of this particular chapter? Let me know once in the chats quickly. I want to know first of all. I want to know first of all. Sir, we need classes daily. Basically, your Ambika ma'am, she was not well, so she's getting back on YouTube day after tomorrow, right? So after tomorrow, from day after tomorrow, you're going to have every day 2 sessions. Okay, you're every day going to have 2 sessions. All right, so I believe everyone has watched the part 1, so it is time for the part 2 to be killed, and this is going to be the super important session when it comes to the chapter mole concept. Okay, so without wasting any sort of time, let's get going. Let's get started, right? Let's get going. Let's get started. So, my dear students, if you remember in the last session, we discussed about the basic terminologies, which involves your atomic mass, molecular mass, molar mass, questions related to them, and eventually we discussed about the average atomic mass of the isotopic mixture as well. Okay. So what all things we shall be discussing in the today's session? It is again going to be basics only, but we'll be starting from the calculation of moles. Then we'll be discussing about the mass, volume, etc. Those relationships, mole conversion diagram, calculation of the moles of atoms, molecules, calculation of electrons, protons, neutrons, ions, etc., etc. And eventually, we'll go to the average molar mass of gaseous mixture, followed by stoichiometry. Okay, so this is going to be a super important session, guys. And you're going to see some amazing new questions, which are particularly for your NEET. Okay, we are going to complete this chapter in 4 sessions. Okay, as I told you already. And I would want you guys to join every session of this particular chapter at least. Okay, that too live. Okay, so let's get going. Let's get started. My dear students, just give me a second. Let me first of all check it if everything is going smooth. Yeah. All right. Calculation of moles. Calculation of moles. How do we calculate number of moles of a substance? How do we calculate number of moles of the substance? Just a second. Yeah, now it's fine. Okay, so my dear students, There are few results which I'm going to give you first of all, which I would want you all to take a note of. What are those results exactly? Result number 1. Number of moles of a substance. Number of moles of a substance, which we represent by N. How do we exactly calculate it? The first result, which I would want every one of you to remember. What is that result exactly? Number of moles of the substance is always equal to, the given mass of the substance in grams divided by the molar mass of the substance. And you know the units of molar mass, that is grams per mole. This is the first result which I would want every one of you to remember from now onwards. Okay? Number of moles of the substance is always equal to given mass of the substance in grams divided by molar mass of the substance. Point number 1. Point number 2. Number of moles of the substance, which we represent by N. It is also equal to given number of particles of a substance divided by what? Divided by Avogadro's number. This is one more result with the help of which we can calculate number of moles of a particular substance. Okay? Given mass of the substance divided by molar mass of the substance, that gives me the number of moles of the substance. This is formula number 1. The second one, given number of particles of the substance divided by Avogadro's number, that also gives me the number of moles of the substance. What it means exactly, you'll get the idea in some time. First of all, take down these points. The third result with the help of which we can calculate the number of moles of the substance, that is equal to, I'll say, number of moles of the substance, or I'll write particularly number of moles of a gas. Number of moles of a gas when the gas is present at STP. Number of moles of the gas when the gas is present at STP is equal to given volume of the gas in liters divided by 22.4 liters. Or you can write it like this as well. It is going to be given volume of the gas in milliliters divided by what? Divided by 22400 ml. So my dear students, these are few results which I would want every one of you to remember first of all. Whenever you're supposed to convert mass into moles, given mass divided by molar mass, that gives me the moles. Given number of particles divided by Avogadro's number, that gives me the moles of the substance. The third result is particularly valid for gases, and the gas has to be present at STP. It is equal to given volume of the gas in liters divided by 22.4 liters. Or if the given volume of the gas is in milliliters, then you are supposed to divide it with 22400 ml. So I would want you guys to remember these results over here. You must be thinking, what is this STP? STP stands for standard temperature pressure. You know it, right? It stands for the standard temperature pressure, right? So first of all, let me show you the application of these results which I wrote over here so that you'll understand how do we use them. My dear students, look at these simple and basic questions over here. You'll understand exactly how do we use these formulas. Try to understand. Calculate the number of moles in 160 grams of NaOH. So basically you are given with 160 grams of NaOH. You have to check how many moles are there in 160 grams of NaOH, right? How many moles are there in 160 grams of NaOH? So as per the question, I'm supposed to calculate the number of moles of NaOH, okay, is equal to. First of all, you need to identify what is given to me as per the question. Look at the given quantity. We are given with the mass of the substance. And whenever mass of the substance is given, which formula do we use? Given mass of the substance divided by molar mass of the substance, that gives me the number of moles. As simple as that, right? Now people try to understand. So I'll write number of moles of NaOH is equal to given mass of NaOH in grams divided by what? Divided by molar mass of NaOH. Divided by molar mass of NaOH. Now my dear students, what is the given mass of NaOH as per the question? That is 160 grams divided by, what is the molar mass of NaOH? What is the molar mass of NaOH? Then sodium, you know, it is 23, oxygen is 16, hydrogen is 1. The value comes out to be 40. And since I want to calculate the molar mass, so its units are going to be grams per mole, right? So 160 divided by 40, the value exactly comes out to be 4. Okay? So what you can understand from here? My dear students, imagine that you have got 160 grams of NaOH in the container. Imagine that you have got 160 grams of NaOH in the container. That actually means you have got 4 moles of NaOH in the container. Okay? That actually means you have got 4 moles of NaOH in the container. As simple as that. Look at the second question. Calculate the number of moles in 67.2 liters of carbon dioxide gas at STP. If you look at this particular question, it's very simple again. First of all, look at the given quantity. What are we given with? Are we given with mass? No. Are we given with volume? Yes. Are we given with the volume of the gas? Yes. Is the gas present at STP? Yes. So which formula I'll be using? Pretty much simple. I'll write number of moles of carbon dioxide is equal to given volume of carbon dioxide in liters, that is 67.2, divided by what? Divided by 22.4. The value exactly comes out to be 3, right? So imagine that you have got 67.2 liters of carbon dioxide. Imagine that you have got 67.2 liters of carbon dioxide in the container at STP. That actually means you have got 3 moles of carbon dioxide in the container. As simple as that. Okay? As simple as that. Now, my dear students, look at another question. Calculate the number of moles in 24 into 10 raised power 23 atoms of carbon. First of all, look at the given quantity. Am I given with the mass? No. Am I given with the volume? No. Am I given with the number of particles? Yes, I am given with the number of particles. What am I supposed to calculate? I'm supposed to calculate moles. How do you calculate moles from particles? You should know it now. I'll write number of moles of carbon is equal to given number of particles, which is 24 into 10 raised power 23, divided by what? Divided by Avogadro's number. And you know your Avogadro's number is approximately 6 into 10 raised power 23. The value comes out to be 4. Correct? So, if you will be having 24 into 10 raised power 23 atoms of carbon in the container, you can directly say you have got 4 moles of carbon in the container. As simple as that. Okay? Now, my dear students, look at the next one. Calculate the number of moles in 48 into 10 raised power 24 molecules of water. So again, look at the given quantity. Are we given with mass? No. Are we given with volume? No. What are we given with? We are again given with particles. And whenever we are given with the particles, what are we supposed to do? Given number of particles divided by Avogadro's number, right? So, number of moles of water will be equal to given number of particles, which is 48 into 10 raised power 24, divided by Avogadro's number. Correct? The value comes out to be 80. Perfect. So, imagine it like this. If you will be having 48 into 10 raised power 24 molecules of water in the container, you can directly say that we have got 80 moles of water in the container. Perfect. So, my dear students, I hope you got to know how do we convert different things into moles. If mass is given, then given mass divided by molar mass. If volume of the gas is given, then given volume of the gas in liters divided by 22.4. If number of particles are given, either in terms of atoms or molecules, then given number of particles divided by Avogadro's number, that gives me the number of moles of the substance. Is this clear to everyone? Let me know once in the chats. Let me know once in the chats if this particular scenario is clear to everyone. Let me know in the chats, people, if this is clear to everyone. Say yes or no in the chats quickly. Perfect, perfect, perfect. Now, let's look at one simple diagram, which is what you call as mole conversion diagram. And with the help of this mole conversion diagram, we can solve some basic, small questions of the mole. Okay? Try to understand, people, what exactly I'm going to do. Try to understand. First of all, I'm going to write number of moles here. Number of moles of the substance. Okay? I'm going to write number of moles of the substance. Now, if I ask you, how many ways do we have to calculate number of moles of the substance? How many ways are there? There are three ways. Either I'll be given with the mass of substance, or I will be given with the number of particles of the substance, or I will be given with the volume of the gas at STP, right? Okay, so either I'll say mass of the substance will be given to us, perfect, or number of particles of the substance will be given to us, or I will say volume of the gas in liters at STP will be given to us. Perfect. Right, people? Now try to understand what exactly I'm going to say. First of all, you know one thing. If mass of the substance is given and we are supposed to calculate moles, if mass is given, moles are to be calculated. How do we do it? Given mass of the substance divided by molar mass of the substance. That gives me number of moles of the substance. Right? As simple as that. If I do the reverse of it, my dear students, imagine you are supposed to convert moles of the substance into its mass. Imagine you are supposed to convert moles into mass. Imagine you are supposed to convert moles into mass. How do you do it? Moles of the substance multiplied by molar mass of the substance. As simple as that. What exactly it means? I'm just telling you, I'm showing you the application of this result. If mass is given, moles are to be calculated, then given mass divided by molar mass. Now, if moles are given, mass is to be calculated. If moles are given, mass is to be calculated. How do you do it? Just moles multiplied by molar mass. That gives me the mass of substance. As simple as that. Okay? If moles are given, mass is to be calculated, then moles multiplied by the molar mass of the substance. That gives me the mass of the substance. As simple as that. Correct? So given mass divided by molar mass, that gives me moles. Now, moles multiplied by molar mass, that gives me the mass. Simple. Similarly, my dear students, given number of particles divided by Avogadro's number, that gives me the moles. Okay? Now, reverse of it. Moles multiplied by Avogadro's number, that gives me the particles. Moles multiplied by Avogadro's number, that gives me the particles in general. Okay? Similarly, given volume of the gas in liters divided by 22.4 liters, that gives me the moles. Given volume divided by 22.4, that gives me the moles. Now, a reverse of it. Moles of the gas multiplied by 22.4 liters. That gives me what? That gives me volume. Okay? Simple. So, my dear students, this is the diagram which you need to remember from now onwards. Given mass divided by molar mass, that gives me moles. Moles multiplied by molar mass, that gives me mass. Okay? Given number of particles divided by Avogadro's number, that gives me moles. Moles multiplied by Avogadro's number, that gives me particles. Given volume of the gas in liters divided by 22.4, that gives me the moles. Moles of the gas multiplied by 22.4 liters, that gives me the volume of the gas. Is this clear to everyone? Say once in the chats. Is it clear to everyone? Say once in the chats. Everyone, people. I'm going to show you how we are going to use this diagram. Okay, I'm going to show you how exactly we are going to use this diagram. Before that, let me know once in the chats if this diagram is clear. Yeah? All right, people. Now try to understand what exactly I'm going to say. Try to understand what exactly I'm going to say. My dear students, for example, look at this question. Look at the first question. Look at the first question. I'll show you how this diagram is applied. Look at the first question carefully. Calculate the mass of 67.2 liters of carbon dioxide gas at STP in grams. Okay. Calculate the mass of 67.2 liters of carbon dioxide gas at STP in grams. So let's try to solve this particular question. The first question. My dear students, first of all, try to understand what are we given with? What is the given quantity here? Are we given with mass? Are we given with volume? Are we given with particles? What are we given with? We are given with volume. We are given with volume. What are we supposed to calculate? We are supposed to calculate mass. We are given with volume. We are supposed to calculate mass. Right? We are given with volume. We are supposed to calculate mass. Okay? We are given with volume. We are supposed to calculate mass. Now tell me one thing. Is there any direct arrow between volume and mass? There is not any direct arrow between volume and mass. So what I'll be doing? what I'll be doing? My dear students, I will be following all the arrows which are going to take me from volume till the mass. I'm going to follow all the arrows which are going to take me from volume till the mass. Since there is no direct arrow between volume and mass, so what I'll be doing? I'll be starting with the volume, right? And then I'll be following all the arrows which will take me from volume till the mass, right? So which all arrows are going to take me from volume till the mass? Look at the path, guys. You have to start from volume. You have to reach till mass, right? So this has to be the path. This has to be the path. So this will be my first step, right? Given volume divided by 22.4 liters, that's going to give me the moles. Then once I get the moles, then I'll be following this arrow. Moles multiplied by molar mass, that gives me the mass. So how many steps are there? There are just 2 steps. The first step, given volume divided by 22.4 liters. That's going to give me the moles, right? So my first step is number of moles of carbon dioxide is equal to given volume of carbon dioxide in liters divided by what? Divided by 22.4. The value comes out to be 3, right? My first step is done. I'll calculate the moles. Now, moles multiplied by molar mass. That gives me the mass. Simple, right? So I'll say mass of carbon dioxide. Mass of carbon dioxide will be equal to moles of carbon dioxide multiplied by what? Multiplied by molar mass of carbon dioxide. So this value will be equal to 3 multiplied by what is the molar mass of carbon dioxide? This will be 44 grams per mole. The value comes out to be exactly 132 grams. Can you let me know the meaning of this 132 grams? My dear students, it simply means that if you will be having 67.2 liters of carbon dioxide gas in the container, if you will be having 67.2 liters of carbon dioxide gas in the container at STP, the mass of 67.2 liters of carbon dioxide gas at STP will be 132 grams. I believe this is clear to everyone. Okay? Simple. Look at the second question. Look at the second question. Calculate the number of molecules. Calculate the number of molecules. Molecules means particles. So we are supposed to calculate particles. What are we given with? We are given with mass. We are given with mass and we are supposed to calculate particles. We are given with mass. We are given with mass and we are supposed to calculate particles. Right? We are given with mass and we are supposed to calculate particles. Is there any direct arrow between mass and particles? No. There is no direct arrow between mass and particles. Right? So my dear students, I will be starting with mass. Then I'll be following all the arrows which are going to take me from mass till particles. Right? I'm going to follow all the arrows which are going to take me from mass till particles. Now what are those arrows? My first arrow, this is going to be the path. This is going to be the path. Right? So this is my first arrow which I'm going to follow. And then this is my second arrow which I'm going to follow. So my first step is going to be given mass of the substance divided by molar mass of the substance. That gives me the moles. Once I get the moles, just multiply that with Avogadro's number. You'll be getting the particles. As simple as that. So what is my first step? My first step is to calculate number of moles of carbon dioxide. That's equal to given mass of carbon dioxide in grams divided by molar mass of carbon dioxide. And this value will come out to be 10. So I calculate the moles. Now, second step, from moles till particles. What do? We just multiply moles with Avogadro's number. Right? So I will say the molecules of carbon dioxide. The molecules of carbon dioxide will be equal to moles multiplied by Avogadro's number. So this is going to be the answer of the question. As simple as that. As simple as that. Is it clear? Is it clear to everyone, people? Let me know once in the chats quickly. I believe yes, it's clear. So, can you solve this question on your own? Can you solve this question on your own? Calculate the volume of 128 grams of SO2. Right? So first of all, try to identify what are we given with. We are given with mass. What are we supposed to calculate? We are supposed to calculate volume. We are given with mass. We are given with mass. We are given with mass. And we are supposed to calculate what? We are supposed to calculate what? We are supposed to calculate volume. We are given with mass and we are supposed to calculate volume. We are given with mass, we are supposed to calculate volume. There is no direct arrow between mass and volume. So I will have to follow all the arrows which are going to take me from mass till volume. From mass till volume. So what all arrows I'll be following? This is the first arrow which I'll be following, right? Then this is going to be the second arrow which I'll be following. So there are 2 steps involved here. There are 2 steps involved here. My dear students, the first step is going to be given mass of the substance divided by molar mass of the substance. That's going to give me the moles. Once I get the moles, multiply that with 22.4 liters. That's going to give me the volume. So there are two steps involved here. Right? My first step, number of moles of carbon dioxide is equal to given mass of carbon dioxide in grams divided by, was this the question? Yes. Let me make it SO2, right? So that calculations will be comparatively easy. Let me make it SO2. Instead of carbon dioxide, I'm writing SO2. Yeah. Now, my dear students, given mass of sulfur dioxide in grams divided by molar mass of SO2, the value exactly comes out be 2. So I got the moles. The second step. Given mass divided by molar mass, that gives me the moles. I got the moles. Now moles multiplied by 22.4 liters, that gives me the volume. So I'll say volume of SO2 at STP is equal to moles of SO2 multiplied by 22.4 liters. So this will be 2 multiplied by 22.4. The value exactly comes out to be 44.8 liters. So what does it mean exactly? It simply means that if you will be having 128 grams of sulfur dioxide in the container, volume occupied by 128 grams of SO2 gas at STP will be exactly how much? 44.8 liters. As simple as that. Let me know once in the chats if it is clear. Look at the next question, guys. Look at this question. The mass of one atom of X is equal to this much. Okay? Calculate the number of moles present in 96 kg of X. What am I supposed to calculate? I'm supposed to calculate moles. What am I given with? I'm given with mass. Right? I'm given with mass. I'm supposed to calculate moles. How do we calculate moles from mass? It is pretty much simple. We are supposed to calculate number of moles of X, which will be equal to given mass of X in grams divided by molar mass of X divided by molar mass of X. Given mass of X in grams divided by molar mass of X. So what is the given mass of X? That is 96 kg. But do we need mass in kg or grams? We need mass in grams. So that's going to be 96,000 grams. We have to divide this with what? We have to divide this with the molar mass of X, right? If you remember in the last session I told you, molar mass of the substance here is X. Molar mass of the substance is equal to mass of one particle of the substance. Mass of one particle of the substance in grams. You're just supposed to multiply this with Avogadro's number, right? This is something which I gave you in the last session. My dear students, what is the mass of one particle of X? That is 4 into 10 raised power minus 23 grams. Just multiply this with Avogadro's number, which is approximately 6 into 10 raised power 23, right? So this term cancelled. 6 4s are 24. So 24 grams is basically the molar mass of X. If you got the molar mass of X, the final answer is going to be 96,000 grams divided by molar mass is 24. The value comes out to be 4,000 over here. So my dear students, what does this 4,000 indicate over here? It simply means one thing. If you will be having 96 kg of X in the container, that means you have got 4,000 moles of X in the container. As simple as that. Killed it. Yeah? Is it clear? Will you be able to solve this sort of equation if it comes? Quickly? Be careful with all these things, yeah? Be careful with all these things, guys. Okay. Look at this question. This has been asked in JEE Mains once. Okay? A simple question, but you need to understand the language of the question carefully. The question says, how many moles of electron weighs 1 kg? How many moles of electrons weighs 1 kg? So understand the language. Like, what are we given with and what are we supposed to calculate? My dear students, we are given with the mass. What are we supposed to calculate? We are supposed to calculate moles. How do we convert mass into moles? You know it. How do we convert mass into moles? So, number of moles of electrons is equal to mass of electron in grams divided by the molar mass of electron. Mass of electron in grams divided by the molar mass of electron. Now, what is the mass of electron that's given to me? What is the mass of electron that's given to me? 1 kg. But do I need the mass in kg or grams? I need the mass in grams. So it's going to be 1000 grams divided by molar mass of electron. Molar mass of electron. In the last session, I've told you how do we calculate molar mass of electron. Molar mass of electron is nothing. It will be mass of one electron multiplied by Avogadro's number. Now, what is the mass of one electron? That is 9.1 into 10 raised power minus 28 grams multiplied by Avogadro's number, approximately this value. Perfect. So the final answer will come out to be, it's going to be 1000 divided by 6 ones are 6, 6 nines are 54, and this is 10 raised power minus 28, 10 raised power 23. It will come out to be 10 raised power minus 5. 10 raised power minus 5 goes up. It will be 10 raised power 8 divided by 54.6. So this is the final answer of the question. These are the moles of electrons which are present in 1 kg of it, right? So if you will be having 1 kg of electron in the container, if you will be having 1 kg of electron in the container, that means you have got these many moles of electrons in the container. I believe this is clear. It is just you were supposed to understand the language of the question, nothing else. Yeah? Perfect, guys? I believe this is clear. All right, look at one more question. You might do a mistake in this particular question. You might do a mistake in this question. My dear students, in this question, we are given with volume. We are given with volume, right? And we are supposed to calculate molecules. Molecules means particles. Molecules means particles. You are given with volume, you are supposed to calculate particles. You are given with volume, you are supposed to calculate particles, right? You are given with volume and you are supposed to calculate particles, correct? So if you are thinking that you will start from volume and you will follow all the arrows which will take you from volume till particles, right? That's something which you'll be thinking, correct? You must be thinking, whatever is the volume given to us as per the question, you'll be dividing that with 22.4. You'll be getting moles. Once you get the moles, you'll multiply that with Avogadro's number. You'll be getting the particles. That's something which I believe you would be thinking. But my dear students, the first result, given volume divided by 22.4, that gives you the moles. But moles of what? Moles of gas. Moles of gas. But if you look at the question carefully, am I given with gas or liquid? I'm given with liquid. So you cannot use the formula given volume of the gas in liters divided by 22.4. You cannot use that formula because that formula is for gases. But here we are not given with gas. We are given with liquid. Correct? We are given with liquid. So what do I do? What do I do? First of all, you know, 1.8 liter means how many milliliters? 1800 ml. So we are given with 1800 milliliters of water. Okay? 1800 milliliters of water. Perfect. My dear students, you must be knowing, since the density of water is 1 gram per ml. Since the density of water, you should be knowing it, it is 1 gram per ml, right? Instead of density of water, you can write mass of water in grams divided by volume of water in ml. Divided by volume of water in ml. This is something equal to 1 gram per ml, right? So can't you calculate mass of water from here? So mass of water will be equal to 1 multiplied by volume of water. Volume of water is 1800 ml. 1800 multiplied by 1. That will come out to be 1800 grams. So what is the first thing which I did over here? I converted the volume into mass. I converted the volume into mass. So 1.8 liter water means we have got 1800 grams of water. We have got 1800 grams of water. Now imagine as if you have to convert mass into particles, right? You know how do we convert mass into particles? That's something which is understood. How do you convert mass into particles? The first step will be calculate the moles of water. That will be equal to given mass of water in grams divided by molar mass of water. The value exactly comes out to be how much? 100. So you got the moles. Now from moles to the molecules. From moles to the molecules. So molecules of water will be equal to moles multiplied by Avogadro's number, right? So this is going to be the final answer. I believe this question is clear to everyone. I believe this particular question is clear to everyone. If it is clear, let me know once in the chats quickly. I hope you got to know. Is it clear, people? Is it clear? Is it clear? Let me know once in the chats quickly. Let me know once in the chats quickly if it is clear. Yeah? So why I did not start with the volume and reached the particles directly? Why I did not divide this with 22.4 to get the moles? That formula is valid for gases, but here it was not gas, it was a liquid. So I converted the volume into mass. Then I started from mass and reached the particles with the help of two steps, right? Then I started from the mass and reached the particles. Then I started from the mass and reached the particles over here. How exactly? Given mass divided by molar mass, that gave me moles. Moles multiplied by Avogadro's number, that gave me the particles. As simple as that. Yeah? So I believe if this sort of equation comes, you should be in a position to solve this sort of equation on your own. Okay? Now, guys. Now comes one more topic, one more small topic in the basic mole. Okay? One small topic in the basic mole. That is calculation of atoms, electrons, protons, neutrons, and even I will write valence electrons. Even I'll write valence electrons. Okay? There is a particular set of questions. There's a particular set of questions, people, which are asked in which you are supposed to calculate either atoms or electrons or protons or neutrons or valence electrons or ions. There are a particular set of questions, right, wherein the calculation of atom is asked, calculation of electrons is asked, calculation of protons, calculation of neutrons, calculation of valence electrons. Anything can be asked out of these. Now, the point is, if the question is asked related to atoms, electrons, protons, neutrons, what do? My dear students, there is one simple diagram which I would want every one of you to follow. Now, what is that diagram? I'm going to write it over here. I'm writing something as given quantity. I'm writing something as given quantity. Whatever is given to us as per the question. Whatever is given to us as per the question. Whatever is given to us as per the question. That is something which I'll be calling directly as given quantity. It can be mass. It can be mass. It can be particles. It can be volume. Okay? It can be mass. It can be particles. It can be volume. Whatever is given to us as per the question, you'll be calling that as given quantity. My dear students, my first step always is going to be to convert given quantity into moles. My first step always is going to be to convert the given quantity into moles. This will be always my first step. Right? Now, my dear students, once we get the moles, then we are supposed to multiply moles with the Avogadro's number. Once we get the moles, we are supposed to get the moles. We are supposed to multiply the moles by the Avogadro's number. What do we get? We will get the molecules if the given substance is in molecular form. If the given substance is in molecular form. What does that mean? You'll get the idea in some time. Okay, first of all, remember this. And once we get the molecules, we can easily calculate everything, including atoms, including electrons, including protons, including neutrons, including ions, including valence electrons, whatever we are supposed to calculate among these terms. Whatever we are supposed to calculate among these terms, anything we can calculate. So you need to remember this diagram first of all. My dear students, first of all, whatever is given to me as per the question, convert the given quantity into moles. Moles multiplied by Avogadro's number. That gives me the molecules if the given substance is in molecular form. Once I get the molecules, we can easily calculate all the other things. Okay? Now, how do we exactly use this? For that, I will solve a question over here. Try to understand, guys. One simple question I'm going to solve with you so that you'll understand what kind of questions can be asked out of this particular small topic. The question is, calculate the total number of atoms. Calculate the total number of atoms in 448 liters of carbon dioxide gas at STP. Calculate the total number of atoms in 448 liters of carbon dioxide gas at STP. So basically, you have got a container in which you have got 448 liters of carbon dioxide gas. You have got a container in which you have got 448 liters of carbon dioxide gas. And you are supposed to check how many total atoms are there in 448 liters of carbon dioxide gas. So my dear students, try to understand. What are we supposed to calculate? We are supposed to calculate atoms. What are we given with? Are we given with mass? No. Are we given with volume? Yes, we are given with volume. What is my first step? What is my first step? Convert the given quantity into moles. Now, in this question, what is my given quantity? I'm given with volume, right? So I'll be converting volume into moles, right? That is the first thing. That is my first thing. Convert the given quantity into number of moles. Now, how do you convert volume into moles? Number of moles of carbon dioxide is equal to given volume of the gas in liters divided by 22.4 liters. The value comes out to be 20. The value comes out to be 20. So my first step is done. I converted the given quantity into moles. Second step. Look at the given substance. Is the given substance in atomic form or molecular form? The given substance is in molecular form. So what I'll be doing? I told you if the given substance is in molecular form, then moles multiplied by Avogadro's number, that gives me the molecules. Correct? So my second step is to calculate number of molecules. Number of molecules of what? Number of molecules of carbon dioxide. That will be equal to 20 multiplied by Na. Moles multiplied by Avogadro's number. So I got the molecules. So try to understand, guys, what exactly we are doing. We had a container, for example. In that container, we had 448 liters of what? Of carbon dioxide. Right? That means in the same container, what do we have? We have got 20 moles of carbon dioxide. Right? Or you can say we have got 20 Na molecules of carbon dioxide in the container. All of these things, it is one and the same thing. Whether you want to say that you have got these many liters of carbon dioxide, or you want to say we have got 20 moles of carbon dioxide, or you want to say we have got these many molecules of carbon dioxide in the container. It is one and the same thing. Correct? Now, tell me one thing. Since we got the molecules, what are we supposed to calculate? We are supposed to get the atoms. Now, tell me one thing. Think logically. My dear students, if I talk about one molecule of carbon dioxide, in one molecule of carbon dioxide, how many total atoms are there? In one molecule of carbon dioxide, there are 2 plus 1, 3 atoms. There are 3 atoms in total. Out of these 3 atoms, there is 1 carbon atom and 2 oxygen atoms. Correct? In one molecule of carbon dioxide, there are 3 atoms, out of which 1 atom is carbon and 2 atoms are oxygen. Now you think about it, guys. Think about it properly. One molecule of carbon dioxide contains 3 atoms. If one molecule of carbon dioxide contains 3 atoms, therefore, 2 molecules of carbon dioxide will contain 3 multiplied by 2 atoms. Correct? 3 molecules of carbon dioxide will contain 3 multiplied by 3 atoms. 4 molecules multiplied by 4. 5 molecules multiplied by 5. 6 molecules multiplied by 6. How many molecules of carbon dioxide we have in the container? 20 Na. So think over it. 20 Na molecules of carbon dioxide will contain 3 multiplied by 20 Na. The value comes out to be how much? 60 Na atoms in total. So in the container, in total, there will be 60 Na atoms, right? Similarly, 1 multiplied by 20 Na. 1 multiplied by 20 Na. The value comes out to be 20 Na what? 20 Na carbon atoms. So there are these many carbon atoms in the container. In the similar way, 2 multiplied by 20 Na, which comes out to be 40 Na. 40 Na what? 40 Na oxygen atoms. So my dear students, in this container right now, there will be in total 60 Na atoms, out of which 20 Na will be the carbon atoms and 40 Na will be the oxygen atoms. This is something which I was supposed to calculate. Done and dusted. Is it clear? Is it clear, people? Yeah? Let's try to solve a few more questions of the same format so that you'll understand what exactly is happening. See, guys. Look at this question. Calculate the total number of atoms, electrons, protons, neutrons in 44.8 liters of carbon dioxide gas at STP. So again, we are supposed to get the atoms. After getting the atoms, we are supposed to get the electrons. Then we are supposed to get the protons, neutrons, etc., etc. Whenever we are supposed to calculate these things, atoms, electrons, protons, neutrons, etc., etc., we are supposed to follow that diagram. And in the diagram, what do we do first? Convert the given quantity into number of moles, right? So identify your given quantity here. We are given with volume. Right? We are given with the volume of the gas. How do we convert volume into moles? Given volume divided by 22.4. That gives me the moles. So first of all, I am calculating the number of moles of carbon dioxide. That's equal to given volume of carbon dioxide in liters divided by 22.4 liters. The value comes out to be 2. Okay. So these many moles of carbon dioxide we have. So are we done with moles? Yes. The first step is done. Second step. Look at the given substance. Is it in atomic form? No. It's in molecular form. So second step. Moles multiplied by Avogadro's number. That will give me the molecules if the given substance is in molecular form. So tell me, how many molecules of carbon dioxide do we have? Molecules of carbon dioxide will be equal to 2 multiplied by Avogadro's number. Right? So these many molecules of carbon dioxide we have. Now it's your choice. Whether you want to say we have got 44.8 liters of carbon dioxide in the container, or you can say we have got 2 moles of carbon dioxide in the container, or you can say we have got these many molecules of carbon dioxide in the container, right? It is one and the same thing. Yeah? Right? So people, try to understand. We got the molecules. Since we got the molecules, after molecules, we can do the calculation of atoms, electrons, protons, etc. So let's do the calculation of atoms first. Tell me one thing. In one molecule of carbon dioxide, how many atoms are there in total? One molecule of carbon dioxide contains in total 3 atoms. Now think over it. If one molecule of carbon dioxide contains 3 atoms, 2 molecules will contain multiplied by 2, 3 molecules multiplied by 3, 4 molecules multiplied by 4. How many molecules do we have? 2Na. So 2Na molecules of carbon dioxide will contain 3 multiplied by 2Na, right? Which comes out to be 6Na. So there are in total 6 Na atoms. present in 44.8 liters of carbon dioxide gas at STP. Right? Done and dusted? So we are done with the calculation of atoms. After doing the calculation of atoms, let's do the calculation of what? Let's do the calculation of electron, proton, neutron. Now guys, this is something basics. Okay? Tell me one thing. In one molecule of carbon dioxide, can you let me know how many electrons, protons and neutrons are there? Can you let me know that? How do we do that? If you take one molecule of carbon dioxide, carbon, oxygen, CO2, atomic number 6, mass number 12. This is 8, this is 16. This is 8, this is 16. So, in one atom of carbon, how many electrons are there? 6. Oxygen, 8. Second oxygen, 8. So, 8, 8, 16, 6. 22. So, one molecule of carbon dioxide contains 22 electrons. Similarly, if I ask you about the protons, this will be 6, this will be 8, this will be 8. So 22 protons as well. Similarly, the neutrons. How do we calculate neutrons? Mass number minus atomic number. So 12 minus 6 is 6, plus 16 minus 8 is 8, plus 16 minus 8 is 8. So 22 neutrons as well. Correct? You got this information? You got the data? The data is pretty much simple. We got to know one molecule of carbon dioxide contains 22 electrons, 22 protons, 22 neutrons. Now think over it. If one molecule of carbon dioxide contains 22 electrons, 2 molecules will contain multiplied by 2, 3 molecules multiplied by 3, 4 molecules multiplied by 4. How many molecules do we have? 2Na. So 2Na molecules of carbon dioxide will contain 22 multiplied by 2Na. That will be 44 Na electrons, right? 22 multiplied by 2 Na, 44 Na protons. Similarly, 22 multiplied by 2 Na, that will be how much? 44 Na neutrons. Isn't this something which I was supposed to calculate? Done and dusted, right? Right, people? All clear? I believe this is clear to everyone. Yes, if it is clear, let me know once in the chats, quickly. I hope this is something which you already know, right? Atomic number is 6, so 6 electrons, 6 protons. Mass, neutrons will be mass number minus atomic number, like that. This is complete basics, which I believe you all would already know. Okay, perfect. Let me solve one more simple question. Let me see if you can do this question or not. One basic question. One basic question. Let me write one simple question, guys. Very, very, very simple. Calculate the atoms. Calculate the atoms in 48 grams of carbon. Calculate the atoms in 48 grams of carbon, right? Calculate the atoms in 48 grams of carbon. Now, if you think logically, what are we given with? We are given with mass, right? This is my given quantity. What am I supposed to calculate? Atoms, right? We are given with mass, we are supposed to get the atoms, right? In order to get the atoms, my first step is convert the given quantity into number of moles. So number of moles of carbon will be equal to given mass of carbon in grams divided by molar mass of carbon. The value comes out to be 4, right? Now look carefully, is the given substance is in atomic form or molecular form? The given substance is in atomic form, right? It's not in molecular form. And if the given substance is in atomic form, at that point of time, moles multiplied by Avogadro's number, that does not give me molecules, that will give me the atoms directly. So atoms of carbon will be equal to moles of carbon multiplied by Avogadro's number. So the value comes out to be 4 Na. Simple, right? So my point here was very simple. If the given substance is in atomic form, at that point of time, moles multiplied by Avogadro's number, that gives me atoms. If the given substance is in molecular form, at that point of time, moles multiplied by Avogadro's number, that gives me molecules. Okay? That gives me molecules. Okay, so let me write it over here separately. If the given substance is in molecular form, then moles multiplied by Avogadro's number, that gives me molecules, right? You can remember it directly like this. If the given substance is in atomic form, then moles multiplied by Avogadro's number, that gives me the atoms directly. If the given substance is in ionic form, for example, then moles multiplied by Avogadro's number, that gives me ions directly. These are some things which I would want every one of you to remember from now on. Okay, let's try to solve a few more questions. Look at this question. Calculate the valence electrons in 4.2 grams of N tri-negative. We are supposed to calculate the valence electrons in 4.2 grams of N tri-negative. So what am I given with? What is my given quantity? I'm given with the mass. Right? So convert the given quantity into moles. So number of moles of N tri-negative will be equal to given mass of N tri-negative divided by molar mass of N tri-negative. Right? Molar mass of N tri-negative will be same as that of molar mass of nitrogen, N. By the presence of charge, nothing happens to the molar mass. Whatever is the molar mass of N, same is going to be the molar mass of N tri-negative. For example, whatever is the molar mass of O, same is the molar mass of O di-negative. Whatever is the molar mass of sodium, same is the molar mass of Na positive, right? So due to the presence of charge, nothing happens to the molar mass, right? So molar mass of nitrogen is 14 grams per mole. The value comes out to be how much? 0.3. So I've converted my given quantity into moles, okay? Now, the given substance is in ionic form. Now, moles multiplied by Avogadro's number, that gives me ions, right? So number of N tri-negative ions will be equal to moles multiplied by Avogadro's number. So these many N tri-negative ions we have. Now people, since you got the n trinegative ions, you got the ions, right? What am I supposed to calculate? Valence electrons. Tell me one thing. Tell me one thing. If I talk about one n trinegative, atomic number 7, mass number 14, right? Okay. If there was no charge on nitrogen, if there was no charge on nitrogen, how many electrons would have been there? There would have been 7 electrons. But it has got trinegative charge. That means it has gained 3 electrons. So 7 plus 3 comes out to be 10. So can I say one n trinegative ion contains 10 electrons in total? If one n trinegative ion contains 10 electrons in total, out of these 10 electrons, 2 electrons will be in the first shell, 8 electrons will be in the second shell, 2,8, right? Correct, people? 2 electrons will be in the first shell, 8 electrons will be in the second shell. This particular shell, which is containing 8 electrons, this is something which I call as the valence shell. And these 8 electrons I'm calling as valence electrons of n trinegative, right? So I'm going to write the simple statement. I'll say one n trinegative ion contains how many valence electrons? 8 valence electrons, correct? People, if one n trinegative ion contains 8 valence electrons, 2 ions will contain multiplied by 2, 3 ions will contain multiplied by 3, 4 will contain multiplied by 4. How many ions do we have? 0.3 Na. So 0.3 Na, n trinegative ions will contain 8 multiplied by 0.3 Na valence electrons. The value comes out to be 2.4 Na valence electrons, which is something I was supposed to calculate. So basically, whenever you'll be having 4.2 grams of n trinegative, it will be having how many valence electrons? 2.4 Na valence electrons. If this is clear, let me know once in the chats quickly. Quickly, people, quickly. Let me know in the chats quickly if this is clear. Yeah? Let me turn the lights on for some time. So basically, because of a lot of lights, I get headache. So that is the reason why I keep on turning these lights off in between. Did you get the concept? How do we solve these sort of questions? Right? Let me give you one more similar question. Let me see if you can solve this or not. The question is pretty much simple. Calculate the valence electrons in 3.2 grams of O di-negative. Right? 3.2 grams of O di-negative. Again, my dear students, in this question, what are we supposed to calculate? Valence electrons. What are we given with? We are given with mass. So my given quantity, what is my given quantity? What is given to me as per the question? I'm given with the mass. I'm supposed to get the valence electrons. What is my first step? Convert the given quantity into moles. Convert the given quantity into moles. So number of moles of O di-negative will be equal to given mass of O di-negative divided by molar mass of oxygen. That will be 16 grams per mole. The value comes out to be how much? 0.2. My first step is done. Second step, check it out. The given substance is in ionic form. And if the given substance is in ionic form, then moles multiplied by Avogadro's number, that gives me the ions. So tell me, how many O di-negative ions do we have? 0.2 Na. So these many O di-negative ions we have, correct? Now tell me, in one O di-negative, how many electrons are there in total? See, atomic number is 8. So if there was no charge on oxygen, at that time, there should have been 8 electrons. But there is di-negative charge. So it has gained 2 electrons. So 8 plus 10 comes out to be 10. So in total, there are 10 electrons in one O di-negative. In total, there are 10 electrons, out of which 2 electrons would have gone in the first shell and 8 electrons would have gone in the second shell. And this second shell will be called as the outermost shell here. And these 8 electrons I will be calling as outermost electrons, or you can call them valence electrons. Okay? So tell me one thing. In one O di-negative ion, how many valence electrons are there? There are 8 valence electrons. In one O di-negative, there are 8 valence electrons. In 2 O di-negatives, multiplied by 2. 3 O di-negatives, multiplied by 3. 4 multiplied by 4. How many do we have? 0.2 Na. So 0.2 Na O di-negative ions will contain 8 multiplied by 0.2 Na valence electrons. The value comes out to be 1.6 Na valence electrons. Correct? So this is something I was supposed to calculate, and I believe it's clear to everyone. If it is clear, let me know once in the chats. If it is clear, let me know once in the chats. Right? All clear, people? Okay. Look at this sort of equation. Look at this sort of equation, and I believe you can easily solve it now. Calculate the atoms in 16 grams of helium. Right? Identify the given quantity. We are given with the mass. By first step, convert the given quantity into number of moles. So number of moles of helium. Number of moles of helium is equal to given mass of helium in grams divided by molar mass of helium. The value comes out to be 4. Right? First step is done. Second step, people. Check the given substance. It is in atomic form. It is in atomic form. Right? So, moles multiplied by Avogadro's number, that will give me the atoms. So, how many atoms of helium do we have? Atoms of helium, how many do we have? It will be 4 Na. That's something I was supposed to calculate. How many atoms of helium are there in 16 grams of it? In 16 grams, there are 4 Na atoms of helium. Correct? Right, people? Simple. Now, look at the second one. Look at the second one. Calculate the atoms in 16 U of helium. What am I given with? I am given with mass. But this mass is not in grams. It is in U. It is in U. It is in U, right? It's in U. You can solve this many ways. You can solve this in many ways. One of the way I'll tell you. First of all, I'm given with the mass of helium in U, right? 16U means 16 multiplied by 1U. And 1U already, you know, 1U is nothing but 1 by Na grams. So you converted the mass into grams first. You converted the mass which was in AMU. You converted this into grams. Now the process is same. Convert the given quantity into moles. What is my given quantity? I'm given with the mass in grams, right? So number of moles of helium will be equal to given mass of helium in grams divided by molar mass of helium, right? The value comes out to be 4 by Na. Perfect. So these many moles we have. Helium is in atomic form, right? If it is in atomic form, so moles multiplied by Avogadro's number, that gives me the atoms directly, right? So how many atoms of helium do we have? Atoms of helium will be equal to 4 divided by Na. Moles multiplied by Avogadro's number, right? The value comes out to be 4. So I can categorically say 16U of helium means 4U of helium. And this is one of the way. Second way, you could have solved it like this. See guys, what is the mass of one atom of helium? It is 4U. 4U is the mass of one atom of helium. If 4U is the mass of one atom of helium, right? Therefore, 1U will be the mass of 1 by 4 atoms of helium. Unitary method. If 4U is the mass of one atom of helium, so 1U will be the mass of 1 by 4 atoms of helium. Therefore, 16U will be the mass of 1 by 4 multiplied by 16. That will be directly 4 atoms of helium. So this is one more way of solving this. Now you can choose any of these two. The choice is yours. Okay. Look at the next question. Look at the next question. Calculate the molecules in 126U of HNO3. Calculate the molecules in 126U of HNO3. Okay. Again, we are given with, check the given quantity. We are given with mass, but this mass is not in grams. It is in U. But I need the mass in grams. How exactly? How exactly? 126U means 126 multiplied by 1U, and 1U already you know, that is 1 by Na grams. Correct? So I am given with the mass of HNO3 in grams. I'm given with mass, I'm supposed to get the molecules. Right? I'm given with mass, I'm supposed to get the molecules. So my first step, convert the given quantity into moles. So moles of HNO3 will be equal to given mass of HNO3 in grams divided by molar mass of HNO3. The value comes out to be 2 by Na. So I got the moles. Now the given substance is in molecular form. Therefore, moles multiplied by Avogadro's number, that gives me the molecules directly. So molecules of HNO3 will be equal to moles multiplied by Avogadro's number. The value comes out to be 2. So 126U of HNO3 means you have got 2 molecules of HNO3. I hope this is clear, right? I hope this is clear. Or you can solve the same question with this approach as well, the second approach. Correct? Am I clear, guys? Say yes or no in the chats. So whatever basic things I've told you, right? You just have to utilize all those basic things. Let me show you. How do you solve the same question with the second approach? See guys, HNO3. You know 63U is basically the mass of one molecule of HNO3, right? It's molecular mass of one molecule. Therefore, 1U will be the mass of 1 by 63 molecules of HNO3. Okay, but am I given with 1U? No, I'm given with 126U. So 126U will be the mass of 1 by 63 multiplied by 126 molecules of HNO3. The value comes out to be exactly 2. So you got to know that 126U means 2 molecules of HNO3. This is one more approach. The choice is all yours, right? The choice is all yours. Okay? If I'm clear, let me know once in the chats, people. Everyone. Everyone means everyone. Then only I will go on to one more topic. I want you guys to let me know in the chats quickly. Quickly, people. All right. Wonderful. Now, there is something which is very important. Okay? There is something which is very important. That is calculation of moles of atoms and molecules. What exactly it means? Try to understand, guys. For example, I'm writing a statement. You tell me whether the statement is right or wrong. For example, I'm writing a statement. 1 molecule glucose, C6H12O6. 1 molecule glucose. My dear students, in 1 molecule of glucose, can I say there are 6 carbon atoms? There are 6 carbon atoms in 1 molecule of glucose. Can I say there are 12 hydrogen atoms in 1 molecule of glucose? Yes. Can I say there are 6 oxygen atoms? There are 6 oxygen atoms in 1 molecule of glucose? Yes, I can say that. 1 molecule of glucose contains 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Now people think over it. For example, I'm multiplying this equation throughout by the Avogadro's number. Let's say I'm multiplying this equation throughout by the Avogadro's number. So 1 multiplied by Na comes out to be Na. So I'll be writing Na molecules of glucose. Na molecules of glucose will contain. I multiplied throughout by the Avogadro's number. So this becomes 6 Na carbon atoms. 6 Na carbon atoms. Here I'm writing 12 Na hydrogen atoms. Right? And here I'm writing 6 Na oxygen atoms. Right? What I did exactly? I multiplied this above equation by the Avogadro's number. Now tell me one thing. Tell me one thing, people. Na molecules of glucose. Na molecules of glucose. That means 6.022 into 10 raised power 23 molecules of glucose. What does that mean? That means 1 mole of glucose. Instead of Na molecules of glucose, I can write 1 mole of glucose. So 1 mole glucose contains 6 Na carbon atoms. 6 Na carbon atoms. What does that mean? 1 mole carbon means Na carbon atoms. 6 mole carbon means 6 Na carbon atoms. So instead of this, I can write 6 mole carbon. And here I'll write 12 mole hydrogen. And here I can write 6 mole O. Correct? So in short, my dear students, in short, I can say 1 mole glucose contains 6 mole carbon, contains 12 mole hydrogen, contains 6 mole oxygen. Yes, I can say that. So from now onwards, you should be able to write this particular statement on your own. Yeah, you should be writing this particular statement on your own. Now I'm erasing all this. I'm writing all these things again. I'm writing all these things again, right? I'm writing all these things again because I need to show you one simple type of question which is frequently asked, right? But before showing you that, you should be in a position to write this sort of a statement. For example, I'm writing 1 mole glucose, C6H12O6. 1 mole glucose contains 6 moles of carbon. 6 mole carbon means 6 Na carbon atoms, right? 6 moles of carbon. Similarly, 12 moles of hydrogen in the atomic form. Similarly, 6 moles of O. 6 moles of O. Correct? Now, guys, remember one thing. Over here, I'm writing a term gram atoms, right? Or I'll write gram molecules. I'll write gram molecules. For example, I'll sometime write gram ions. Let me tell you, gram atoms, gram molecules, gram ions. It is nothing. It is a name given to moles. It is a name given to moles. Sometimes, if they ask you to calculate the number of gram atoms, that means you're supposed to calculate moles. Calculate the gram molecules, that means you're supposed to calculate moles. Calculate the gram ions, you're supposed to calculate moles. Nothing else. Okay, just to confuse you. Gram atoms, gram molecules, gram ions. It means moles. Okay? Now. Understand what exactly I'm going to say. Understand what exactly I'm going to say. My dear students, if you look at this particular statement, over here I've taken hydrogen in atomic form. Here I've taken hydrogen in atomic form. Right? So, over here I've taken hydrogen in atomic form. If I want to take this hydrogen in molecular form, then I will be writing 1 mole of glucose contains. I won't be writing 12 moles of H. I'll be writing 6 moles of H2. I've taken hydrogen in molecular form here, right? 6 to 0 comes out to be 12 moles of H only. Okay. Similarly, here I took oxygen in atomic form. If I want to take oxygen in molecular form, how do I take it? 6 mole O means 3 mole O2. 3 mole O2. Correct? I hope you're getting what I'm trying to say. I hope you're getting what I'm trying to say. And my dear students, understand one thing now. Here, hydrogen is in atomic form. Hydrogen is in atomic form. So instead of this mole, you can use the term gram atom. So you can say 1 mole glucose contains. Either you will say 12 moles of H or you can say 12 gram atoms of hydrogen. Choice is yours. Here again, oxygen is in atomic form. Either you can say 6 moles of O or 6 gram atoms of oxygen. But here hydrogen is in molecular form. Correct? Either you will say 6 moles of H2 or you can say 6 gram molecules of hydrogen. You'll say 6 gram molecules of hydrogen. Oxygen is in molecular form. Here oxygen is in molecular form. Right? Either you will say 3 moles of O2 or 3 gram molecules of oxygen. I believe I'm clear with this. I'll show you one more statement. I'll write one more statement so that it becomes clear. If I write 1 mole H2SO4, 1 mole H2SO4. First of all, 1 mole H2SO4, it contains 2 moles of H in atomic form. It contains 4 moles of O. Again, I've taken oxygen in atomic form. Since hydrogen here is in atomic form, so instead of mole, you can write 2 gram atoms of oxygen. Sorry, 2 gram atoms of hydrogen. 2 gram atoms of hydrogen. Here you have written 4 moles of O. Again, oxygen is in atomic form. You can write 4 gram atoms of oxygen. 4 gram atoms of oxygen. Now. Tell me one thing. Instead of 2 moles of H, can I write 1 mole H2? Yes, I can write 1 mole H2. Similarly, instead of 4 moles of O, can I write 2 moles of O2? Yes, I can write 2 moles of O2. Now, my dear students, tell me, here hydrogen is in molecular form, here oxygen is in molecular form. So, instead of 1 mole of H2, I can write 1 gram molecule of hydrogen. 1 gram molecule of hydrogen, because here hydrogen is in molecular form. Here oxygen is also in molecular form. So, instead of 2 moles of O2, I can write 2 gram molecules of oxygen. Perfect. I believe this sort of a statement is perfectly clear to everyone. If it is clear, let me know once in the chats. Then only I'll show you its application part. Where do I use this? Right? A lot of students, they get confused in these sort of statements. That's why I showed you all of this in detailed format. So I want every one of you to let me know in the chats if it is clear. Yeah? I want you guys to let me know in the chats if it is super clear. Perfect. Guys, say it in the chats quickly. I'm teaching every single thing in very, very, very detailed format. Very detailed. And trust me, on YouTube, you are not going to get this much of detailed content on mole. What is this Yaria 2.0? All clear? Perfect. Let me show you where do I use this sort of a statement. See guys, look at this simple and basic question. A very simple and basic question. They're asking you to calculate the moles of O. They're asking you to calculate the moles of O present in 196 grams of H2SO4. Calculate the moles of O in 196 grams of H2SO4. Okay? You're not supposed to calculate atoms of oxygen. You're supposed to calculate moles of O present in 196 grams of H2SO4. First of all, convert the given quantity into moles. What is my given quantity? It's mass. So convert the mass into moles. Number of moles of H2SO4 will be equal to given mass of H2SO4 in grams divided by molar mass. The value comes out to be 2. Right? The value comes out to be 2. So basically, I'm given with 2 moles. Basically, I'm given with 2 moles of H2SO4. Now think logically, guys. Think logically. If I talk about 1 mole H2SO4, tell me in 1 mole H2SO4, how many moles of O are there? Can I say 1 mole H2SO4 contains 4 moles of O? This is something which we already know, right? 1 mole H2SO4 contains 4 moles of O. Now think carefully. If 1 mole H2SO4 contains 4 moles of O, therefore 2 moles of H2SO4 will be containing 4 2s are 8. 8 moles of O. Wasn't this something which I was supposed to calculate? I was supposed to calculate the moles of O. I was supposed to calculate the moles of O which are present in 196 grams of H2SO4, which are present in 2 moles of H2SO4. So I got to know in 2 moles of H2SO4, there are total 8 moles of O present. Clear? Am I clear? Okay. Right, people? Or instead of 8 moles of O, what you can write? Since oxygen here I have taken in atomic form, you can write 8 gram atoms of O. 8 gram atoms of oxygen. So it is not necessary that they'll ask you directly to calculate the moles of O. They can ask you to calculate the gram atoms of O, which means you're supposed to calculate moles of O only. Yeah? Perfect? Okay, guys? Okay, tell me one thing. In this question, whose data I was supposed to calculate? Was I supposed to calculate the data for H2SO4 or data of O? Whose data I was supposed to calculate? I was supposed to get the data. I was supposed to calculate the data of O. Remember, the one whose data is to be calculated, that always has to be on the right side of the statement. That always has to be on the right side of this statement. The one whose data is to be calculated, that has to be on the right side of the statement. Yeah? Okay? Remember this. The one whose data is to be calculated, that has to be on the right side of the statement. Let me show you one more question. Look at this one. Someone was asking about the JEE Mains PYQ. This is your JEE Mains PYQ. Okay? Look at the question. Calculate the mass of H3PO4. Calculate the mass of H3PO4 that contains 0.25 moles of O. Calculate the mass of H3PO4 that contains 0.25 moles of O. What mass of H3PO4 will contain 0.25 moles of O? Think over it. My dear students, if I, for example, talk about 1 mole H3PO4, can I say in 1 mole H3PO4 there are 4 moles of O? Yes. 1 mole H3PO4 contains 4 moles of O. But look at the question carefully. Whose data I am supposed to calculate? I am supposed to calculate the data for H3PO4. The one whose data is to be calculated, that has to be on the right side of the statement. Right? So what I'll be doing? I'll be reversing the statement. And after reversing the statement, I can say 4 moles of O are present in 1 mole H3PO4. 4 moles of O are present in 1 mole H3PO4. Now tell me one thing. If 4 moles of O are present in 1 mole of H3PO4, use the unitary method. Something which we study in class 6, 7. If 4 moles of O are present in 1 mole H3PO4, therefore 1 mole of O will be present in 1 by 4 moles of H3PO4. Right? 1 mole O will be present in these many moles of H3PO4. Therefore, as per the question, 0.25 moles of O, 0.25 moles of O will be present in 1 by 4 multiplied by 0.25. The value comes out to be 1 by 16 moles of H3PO4. Tell me the meaning of this. What did I get here? What did I get? These are the moles of H3PO4. These are the moles of H3PO4 that contains 0.25 moles of O. These are the moles of H3PO4 that contains 0.25 moles of O. But, am I supposed to calculate moles of H3PO4 as per the equation? No, I'm supposed to calculate mass of H3PO4. Do you remember how do you convert moles into mass? Do you remember that? How do you convert moles into mass? So I'll write mass of H3PO4 that contains 0.25 moles of O will be equal. How do you convert moles into mass? Moles multiplied by molar mass. Moles are 1 by 16. Molar mass of H3PO4 is 98 grams. The value comes out to be 6.125 grams. So what is the meaning of this 6.125 grams? This is the mass of H3PO4. This is the mass of H3PO4 that contains 0.25 moles of O. This is the mass of H3PO4 that contains 0.25 moles of O, which is something I was supposed to calculate. Right? What mass of H3PO4 contains? 0.25 moles of O. And I got to know 6.125 grams of H3PO4 contains 0.25 moles of O. If this is clear, let me know once in the chats. Quickly, people. Can you solve this question now? Can you solve this question on your own? Look at the question carefully and tell me in the chats whether you will be able to solve this or not. Quick, people. Everyone. Quickly. Everyone. All right. If you look at this particular question, the question says calculate the mass of H3PO4. Calculate the mass of H3PO4 that contains 0.25 moles of O2. Here oxygen is in molecular form. Right? Now guys, tell me one thing. If I write the statement, 1 mole H3PO4 contains how many moles of O2? Contains how many moles of O2? Tell me quickly. I'll say it contains 2 moles of O2. It contains 2 moles of O2. Right? It contains 2 moles of O2. Whose data am I supposed to calculate? I'm supposed to calculate the data for H3PO4. The one whose data is to be calculated, that has to be on the right side of the statement. So I can say 2 moles of O2. 2 moles of O2 are present in 1 mole of H3PO4. Now think over it. If 2 moles of O2 are present in 1 mole of H3PO4, therefore 1 mole O2 will be present in 1 by 2 moles of H3PO4. Okay? And as per the question, 0.25 moles of O2. 0.25 moles of O2 will be present in 1 by 2 multiplied by 0.25. The value comes out to be 1 by 8 moles of H3PO4. Now think logically like what we calculated. What is this term? My dear students, these are the moles. These are the moles of what? These are the moles of H3PO4 that contains 0.25 moles of O2. But as per the question, was I supposed to calculate the moles of H3PO4? No, I was supposed to calculate the mass of H3PO4. How do I convert moles into mass now? I'll simply write mass of H3PO4 will be equal to moles of H3PO4 multiplied by what? Multiplied by molar mass of H3PO4. The value comes out to be how much? 12.2. 0.25 grams. So this is the mass of H3PO4 that contains 0.25 moles of O2, which is something I was supposed to calculate. If it is clear, let me know once in the chats quickly. Let me know once in the chats if this particular thing is clear. Is it clear to everyone? Quickly. Quickly, people. Yes? Is it clear? Yeah? I believe this is clear to everyone. Okay? Now, let's move on to one more important topic. Average molar mass of a gaseous mixture. Average molar mass of a gaseous mixture. Have you studied this topic before? Just let me know once in the chats. Have you studied this topic before? Let me know once in the chats. All right, guys. Okay, you have not studied this topic before. So let's get to know about this particular topic exactly from the basics, from the scratch only, right? So my dear students, the first topic. The topic is average molar mass of the gaseous mixture. Average molar mass of the gaseous mixture. First of all, the average molar mass of the gaseous mixture, how do we exactly define it? Try to understand. It is defined as the mass of 1 mole of a gaseous mixture. It is defined as the mass of 1 mole of a gaseous mixture. Mass of 1 mole of a gaseous mixture. What does that mean? You'll get the idea in some time. Number two. This average molar mass of the gaseous mixture, it is represented by MAV. This is how you represent it. Okay. Third, it is expressed in grams per mole. It is expressed in grams per mole. Now let's try to understand what exactly it means. Have a look, guys. This is something which is important. For example, this is the container. Imagine this is the container. Okay. For example, in this particular container, I am keeping, let's say, 2 gases. One is your N2 gas and one is your O3 gas. For example, these are the 2 gases, 2 chemically non-reacting gases which are there in the container. Let's say these are the 2 chemically non-reacting gases which are there in the container. Okay. I'm, for example, assuming there are 2 moles of N2 in the container as well as 2 moles of ozone in the container. This is again something which I'm assuming. I'm assuming there are 2 moles of N2 gas and 2 moles of ozone gas there in the container. Okay? Right? Now, my dear students, since there are 2 gases, 2 chemically non-reacting gases in the container, so can I say I have got a gaseous mixture in the container? Can I say I have got a gaseous mixture in the container, which contains exactly how many gases? 2 gases, right? So first of all, if I ask you one simple thing, what is the molar mass of N2? You'll say molar mass of N2 is 28 grams. What does that mean? That means the mass of 1 mole of N2 is 28 grams. But do we have 1 mole of N2 or 2 moles of N2? We have 2 moles of N2. If the mass of 1 mole of N2 is 28 grams, therefore mass of 2 moles of N2 will be 28 into 2. That means 56 grams. So this is the mass of 2 moles of N2 in the container. Right? Similarly, guys, what is the molar mass of ozone? What is the molar mass of ozone? 48 grams. That means the mass of 1 mole of ozone is 48 grams. If the mass of 1 mole of ozone is 48 grams, therefore mass of 2 moles of ozone is 48 into 2, that is 96 grams. So in this container right now, there are 56 grams of N2 present, there are 96 grams of ozone present. Or you can talk in terms of moles as well. There are 2 moles of N2 and 2 moles of O3 present. Now tell me one thing. If I ask you one simple thing, how many total moles are there in the mixture? How many total moles are there in the mixture? 2 plus 2, 4. What is the mass of the gaseous mixture? What is the mass of entire mixture? 56 plus 96. That comes out to be 152 grams. Right? Correct? So the total mass of the mixture is 152 grams. Total moles present in the mixture is equal to 4. Okay? Now guys, I'm going to write a simple statement. Can I say 4 moles of a gaseous mixture? 4 moles of a gaseous mixture has got the mass of 152 grams? Yes. 4 moles of the gaseous mixture has got the mass of 152 grams. Now tell me one thing. If 4 moles of the gaseous mixture has got the mass of 152 grams, tell me, use the unitary method. What will be the mass of 1 mole of a gaseous mixture? The mass of 1 mole of a gaseous mixture will be 152 divided by 4 grams. Can you say this is the mass of 1 mole of the gaseous mixture? Right? This is the mass of 1 mole of the gaseous mixture. Look at the definition. The mass of 1 mole of the gaseous mixture is something which you call as average molar mass. Right? So this is the mass of 1 mole of the gaseous mixture. Right? And this is something I'll be calling as average molar mass of this mixture which I've kept in the container. Let me know in the chats if you got the concept. Let me know in the chats if you got the concept. Quickly. Quickly, people. Everyone, quickly. Yeah? Right? So this is the mass of this is the mass of 1 mole of the gaseous mixture. And the mass of 1 mole of the gaseous mixture is what you call as average molar mass. Right? My dear students, tell me one thing. Tell me one thing. Look at this box. In this box, how many terms are there? There are 2 terms. One is 152, another one is 4. Right? If you look at this box and I want you guys to calculate, I want you guys to make a direct formula. I want you guys to make a direct formula to calculate the average molar mass. I do not want you guys to do all this stuff. Okay? I want you guys to make a direct formula to calculate average molar mass of the mixture. Can I say average molar mass of the mixture will be equal? What was this 152? This was the mass of gaseous mixture. This was the mass of mixture in grams. Divided by, what was this 4? What was this 4? These were the total moles present in the mixture. Total moles present in the mixture. So this becomes my direct result. This becomes my direct result with the help of which I can calculate the average molar mass of the gaseous mixture. Yeah? Okay? Correct? This becomes my direct formula with the help of which we can calculate average molar mass of the gaseous mixture. So my average molar mass of the gaseous mixture becomes mass of the mixture in grams divided by total moles present in the mixture. This is the formula with the help of which we can calculate average molar mass of the mixture. Okay? Perfect? Right, people? The direct result. Imagine if you knew this formula before. Imagine if you knew this formula before. You were not supposed to do this procedure. What you were supposed to do? Mass of the mixture, that is 152. Put it here. Total moles present in the mixture, that's 4. 152 divided by 4 grams per mole. That would have been the answer. Yeah? Now guys, let me particularly make certain results with the help of which we can calculate the average molar mass of the mixture. Okay, let me make certain results. Now, how do I make the results? So that you'll understand what kind of questions can be asked. I'm going to create a scenario over here. Imagine this is the container. Imagine this is the container. Okay. And in this container, for example, you have got two chemically non-reacting gases, gas 1 and gas 2. You have got two chemically non-reacting gases in this container, gas 1 and gas 2. My dear students, I'm assuming there are N1 moles of gas 1 in the container and 2 moles of gas 2 in the container. This is something which I'm assuming. Moles of gas 1, moles of gas 2 in the container. Mass of gas 1 in grams, mass of gas 2 in grams, right? What is the mass of gas 1 in the container? W1 grams. What is the mass of gas 2 in the container? W2 grams, right? Molar mass of gas 1, M1. Molar mass of gas 2, M2, right? So molar masses of the gases in the container, M1, M2 respectively. Let's assume volume of gas 1 is V1, volume of gas 2 is V2 in the container. This is volume. This is volume, okay? For example, mole fraction. Mole fraction of gas 1 is chi1, mole fraction of gas 2 in the container is chi2. This is mole fraction. Mole fraction, okay? Perfect. Now guys, try to understand what exactly I'm going to do. Try to understand very carefully. So first of all, if I ask you, what is the mass of the entire mixture? Mass of the whole mixture will be W1 plus W2. Mass of the gaseous mixture is equal to W1 plus W2. How many moles are there in the mixture? How many moles are there in the mixture? N1 plus N2. N1 plus N2, right? Now guys, think logically. Instead of mass of the mixture, you can write it like this as well. W1 plus W2 divided by N1 plus N2. Correct? You can calculate it with the help of this particular result as well. Now tell me one thing. Tell me one thing. Number of moles of the substance is equal to given mass of the substance divided by molar mass of the substance. Right? So N1, what is N1? Number of moles of gas 1. Can I say number of moles of gas 1 will be equal to mass of gas 1 divided by molar mass of gas 1? Right? So what about mass of gas 1? Mass of gas 1 will be equal to simply M1N1. Mass of gas 1 will be equal to M1N1. Mass of gas 2 will be equal to M2N2. Therefore, M average can be written as, instead of W1, you can write M1N1. Instead of W2, you can write M2N2 divided by what? Divided by N1 plus N2. This becomes my one more result with the help of which you can calculate average molar mass of the gaseous mixture. Okay. Now guys, think logically. Think logically. This N1 plus N2, this is the denominator of this term as well as the denominator of this term. Okay. So I can write it like this. MAV is equal. I can write M1N1 divided by N1 plus N2. Right? In the middle, it's plus. It is M2. N2 divided by N1 plus N2. Right? Have you heard about this particular term? If I write M1 as such, N1 divided by N1 plus N2. Number of moles of gas 1 in the container divided by total moles present in the container. What do I call this as? I call this as mole fraction of gas 1. Similarly, M2 multiplied by what? Multiplied by mole fraction of gas 2. So this is one more result in terms of what? In terms of mole fraction. In terms of mole fraction. One more result in terms of mole fraction. M1 chi1 plus M2 chi2. Okay? M1 chi1 plus M2 chi2. Perfect, guys? Now, one more thing. Let me erase this part. I want you guys to remember the results only. Okay? My dear students, remember one more thing. If this gaseous mixture was present at constant pressure and temperature, if the pressure and temperature of the mixture was constant, that means if the pressure and temperature of the mixture was not changing at that point of time, how do we calculate M average? How do we calculate the average molar mass? There is a result. M1V1 plus M2V2 divided by what? Divided by V1 plus V2. This is the result. This is the result with the help of which we can calculate average molar mass of the mixture when the mixture is kept at constant pressure and temperature. If the pressure and temperature of the mixture is kept constant, right? If the pressure and temperature of the mixture is kept constant at that point of time, how do you calculate average molar mass? This is the formula. M1V1 plus M2V2 divided by V1 plus V2. But this is not the formula which you will use everywhere. No, this is the formula which you will use only if the pressure and temperature of the mixture is kept what? Is kept constant. Perfect. I believe this is clear. I believe this is clear. I believe this is clear. Okay, perfect. All right, guys. So let's try to see exactly how do we utilize these results in the questions. Let's try to see how do we utilize these results in the questions. But before seeing the questions, let me tell you one more thing. Have you ever heard of mole percentage? Mole percentage is nothing. It is mole fraction multiplied by 100, right? It is mole percentage is nothing. It is mole fraction multiplied by 100. Perfect. So M average, you can make one more formula. You can write M1 as such, mole fraction of gas 1. Instead of mole fraction of gas 1, you will write mole percentage of gas 1 divided by 100. You'll write mole percentage of gas 1 divided by 100 plus M2, mole fraction of gas 2. You can write mole percentage of gas 2 divided by 100. Okay, this is one more result in terms of mole percentage, right? Now, these are many results. Let's try to utilize these results in the questions. See, guys, look at the first question. Look at the first question. Look at the first question. Carefully look at the first question. This is one basic, this one simple question, guys. As per this particular question is concerned, you have got a container, and in this container, there are three gases present. Gas A, gas B, and gas C. These are the three gases present in the container. What is the mass of gas A in the container, which I'm representing with W1? What is the mass of gas A in the container? It is 4.4 grams. What is the mass of gas 2 in the container? Mass of gas 2 in the container is how much? How much is it? 6.4 grams. What is the mass of gas 3 in the container? What is the mass of gas 3 in the container? It is 4.8 grams. 4.8 grams, right? As per the question is concerned, do you know the molar mass of these gases? Yes. What is the molar mass of gas 1? 44 grams per mole. What is the molar mass of gas 2? 64 grams per mole. What is the molar mass of gas 3? It is 48 grams per mole. This is the data that is given to me. What am I supposed to calculate? I'm supposed to calculate the average molar mass of the mixture. I'm supposed to calculate the average molar mass of the mixture. That means I'm supposed to calculate mass of 1 mole of a gaseous mixture. Now, there are a lot of results which we know. But which result am I going to use? Am I going to use the mass result, moles result, volume result, mole fraction, mole percentage? Since masses are given, I'll directly use the mass result. So I'll write mass of gas 1 plus mass of gas 2 plus mass of gas 3 divided by. It's going to be N1 plus N2 plus N3. Okay, what is W1? W1 is nothing, that is 4.4 plus W2 is 6.4, W3 is 4.8 divided by, what is N1? Number of moles of gas 1. Number of moles of gas 1 means mass of gas 1 divided by molar mass of gas 1. So this by this, that comes out to be 0.1. Number of moles of gas 2. Number of moles of gas 2 will be equal to mass of gas 2 divided by molar mass of gas 2, which will be also 0.1. Similarly, mass of gas 3 divided by molar mass of gas 3, again 0.1. So what is the value which you'll be getting over here? How much is the value you are getting after doing the calculation? Can you let me know in the chats? What is the value which you are getting after doing the calculation? Quickly. Quickly, guys. Quickly, people. Quickly, people. How much is it? 8, 4, 12, 4, 16, 4, 1, 5, 6, 5, 11, 11, 4, 15. So 15.6 divided by 0.3, right? So this comes out to be how much? 35, 32. 52, and it's expressed in grams per mole, right? So 52 grams per mole is basically, 52 grams per mole is basically the average molar mass of the gaseous mixture over here. It is the mass of 1 mole of the gaseous mixture over here. I hope this is clear. Okay, for example, if I modify the equation, if I ask you to calculate the mass of 5 moles of the gaseous mixture which is given to you. For example, in the question they ask you, calculate the mass of 5 moles of the gaseous mixture. What do you do in this particular case? First of all, you got the average molar mass of the mixture as 52 grams per mole. What does it mean? It means that mass of 1 mole of the mixture is 52 grams, right? It means that mass of 1 mole of the mixture is 52 grams. Now, if the mass of 1 mole of the mixture is 52 grams, therefore, mass of 5 moles of the mixture will be 52 multiplied by 5 grams. Simple. This can be also asked. It's not necessary always. They'll ask you the average molar mass. They can ask you to calculate the mass of 10 moles of the gaseous mixture, 20 moles of the gaseous mixture, etc., etc. Okay? All right, look at this question. It's again simple and basic. It's again simple and basic, guys. As far as this particular question is concerned, see, you've got a mixture that contains 2 gases, carbon dioxide, and with carbon dioxide, you've got O2. Let me call carbon dioxide as gas 1. Let me call O2 as gas 2. First of all, do you remember their molar masses? Yes. Molar mass of carbon dioxide is 44 grams per mole. Molar mass of oxygen is 32 grams per mole. You know it. Okay. Now, as per the question, mole percentage of carbon dioxide. Mole percentage of carbon dioxide is 60. Now, think logically. If mole percentage of carbon dioxide is 60, what will be the mole percentage of oxygen? Sum of percentage is always 100. So, mole percentage of oxygen is 40. Right? What am I supposed to calculate? What am I supposed to calculate? The average molar mass of the gaseous mixture. Okay? For example, I'm modifying the equation. Calculate the mass of 10 moles of a gaseous mixture. Let's say this is the question. Calculate the mass of 10 moles of the gaseous mixture. My dear students, in order to calculate the mass of 10 moles of the gaseous mixture, first of all, I need to calculate the mass of 1 mole of the gaseous mixture. Right? Once I get the mass of 1 mole of the gaseous mixture, I'll be multiplying that with 10. I'll be getting the mass of 10 moles of the mixture. As simple as that. Right? Now think logically. Let's try to calculate the mass of 1 mole of the gaseous mixture. That means let's calculate the average molar mass. Because average molar mass of the mixture means the mass of 1 mole of the mixture. Right? Perfect. Right? Now, guys, average molar mass of the mixture. Which formula I'll be using? Since I'm given with the data of mole percentage, so I'll be using that formula only. M1 multiplied by mole percentage of gas 1 divided by 100 plus M2 multiplied by mole percentage of gas 2. Mole percentage of gas 2 divided by 100. Correct? So your M average from here comes out to be, what is M1? 44. So 44 multiplied by 60 by 100 is 0.6 plus, what is M2? M2 is 32 and mole percentage of gas 2 is 40. 40 by 100 is 0.4. Can you let me know how much this value comes out to be after solving? MAV value? How much it comes out to be? Quickly, guys. How much this value comes out to be? 39.2, yeah? So this value comes out to be 39.2 grams per mole. This is the average molar mass of the mixture. This is the mass of 1 mole of the gaseous mixture. You can look carefully. Mass of 1 mole of the gaseous mixture is how much? 39.2 grams. So I'll write it like this manner only. The mass of 1 mole of the gaseous mixture is how much? The mass of 1 mole of the gaseous mixture is 39.2 grams. Now tell me, if the mass of 1 mole of the mixture is 39.2 grams, what will be the mass of 10 moles of the mixture? The mass of 10 moles of the gaseous mixture will be how much? 39.2 multiplied by 10. The value comes out to be 392 grams. This is the mass of 10 moles of the gaseous mixture which I was supposed to calculate. So my dear students, you can expect this sort of a question as well. Isn't it simple? Isn't it simple? All right, moving ahead. Moving ahead, guys. Moving ahead. Look at this question. Look at this particular question. Understand what the question says. At 27 degrees centigrade and 1 atm, you've got a gaseous mixture containing what? You've got a gaseous mixture containing O2 and SO2. Right? At 27 degrees centigrade, you've got a mixture containing O2 and SO2. In 2:1 volume ratio. In 2:1 volume ratio. In 2:1 volume ratio. Okay? Calculate the total number of moles present in 20 grams of the mixture. So you have to calculate total moles present in 20 grams of the mixture. So as per the question, what is the mass of mixture that's given to me? 20 grams. What am I supposed to calculate? Total moles present in the mixture. This is something I need to calculate. Total moles present in the mixture. Tell me one thing. Few minutes back only we saw one result directly. M average is equal to mass of the mixture divided by total moles in the mixture. Right? I'll be using the same result. I'll be using the same result. How come? Try to understand. Try to understand. We know one result which I got to know few minutes back. M average is equal to mass of the mixture in grams divided by total moles present in the mixture. So that means total moles present in the mixture will be equal to mass of the mixture in grams divided by what? Divided by M average. Right? Divided by M average. Now, what is the mass of the mixture? As per the question, mass of the mixture is nothing but 20 grams. I just need to calculate what? I just need to calculate M average, put it here and get the total moles present in 20 grams of the mixture. That's it. That's it, right? Now the point is, how do I get the M average over here? How do I calculate the average molar mass of the mixture? This is simple. My dear students, try to understand. If I call oxygen as gas 1, SO2 as gas 2, what is the molar mass of gas 1 here? It will be 32 grams per mole. Molar mass of gas 2 will be 64 grams per mole. Correct? As per the question, the mixture that is given to us, the mixture is kept at constant pressure and temperature. The mixture is kept at constant pressure and temperature. And people, you know, at constant pressure and temperature, how do I calculate the average molar mass? You know the formula, M1V1 plus M2V2 divided by what? Divided by V1 plus V2. This is the formula. This is the formula, right? Now understand carefully. Understand carefully. Volume ratio is given to us as 2:1. If the volume ratio is 2:1, that means if the volume of SO2 is x ml, so volume of O2 has to be 2x ml, right? Let's call this as V1. Let's call this as V2. Simple. Let's call one as V1. Let's call one as V2. So M1 multiplied by V1. M1 multiplied by V1. 32 multiplied by 2x comes out to be 64x plus M2 multiplied by V2. M2 multiplied by V2. 64 multiplied by x is 64x divided by V1 plus V2. 3x plus 2x plus x makes it 3x. X cancel everywhere. So it is 128 divided by 3 and it's going to be grams per mole. So you got the average molar mass. If you got the average molar mass of the mixture, put it here. You are done. So it will be 20 grams divided by. This will be 128 divided by 3 grams per mole. So the value finally comes out to be 60 divided by 128. So 60 divided by 128 is the final answer. So what is this? What is this? You got to know the total moles present in 20 grams of the mixture over here. That's something which I was supposed to calculate. Okay. Why did I use this formula? The volume result? Because the pressure and temperature of the mixture was kept constant. And at constant pressure and temperature, you have got only one result with the help of which you can calculate average molar mass. Perfect, guys? So 60 upon 128 is the final answer. I hope I'm perfectly clear to everyone. Let me show you one more question. This might be slightly difficult for you, but let's give it a try. Let's give it a try. We have got a lot of time left, right? We have got a lot of time left till NEET 2025, correct? So it's better to discuss every single thing in detail. Look at the question, guys. As far as this particular question is concerned, try to understand. Imagine that you have got a container, and in this container, you have got a mixture containing O2 and O3. So there is O2 gas and O3 gas in the mixture. As far as the question is concerned, the volume of this whole mixture is 600 ml. Right? Volume of this whole mixture is 600 ml. Perfect. And as per the question, 600 ml mixture of O2 and O3 at STP weighs 1 gram. So I can say the mass of this entire mixture is 1 gram. And 1 gram of this mixture at STP occupies the volume of how much? 600 ml. So you are given with the volume of this mixture as well. Mass of this mixture is given to me as 1 gram, right? And the volume of this mixture is given to me as 600 ml as per the question. Okay, 1 gram of the mixture containing O2 and O3 has got the volume of 600 ml over here. 1 gram of the mixture containing O2 and O3 has got the volume of 600 ml over here. Now guys, try to understand. What are we supposed to calculate? Calculate the volume of ozone in the mixture. How do I get the volume of ozone? How do I get the volume of ozone? How do you do it? Do you get any idea of solving this question? Understand how exactly I'm going to solve this. First of all, the gaseous mixture which we have, the mass of the entire gaseous mixture is 1 gram. The volume of the entire gaseous mixture is 600 ml. And the mixture is present at STP. Okay, the mixture is present at STP. Now, if the volume of the entire mixture is X ml, let's assume that if the volume of the entire mixture is 600 ml, let's assume that out of 600 ml mixture, there are X ml of ozone and there will be 600 minus X ml of oxygen in the mixture. I assumed one simple thing. Let the volume of ozone in the mixture is X. Therefore, volume of oxygen in the mixture will be 600 minus X. Correct? Because the volume of the entire mixture is 600. Out of 600, let the volume of ozone be X. Volume of oxygen will be 600 minus X. Right? Now guys, understand. What is the molar mass of oxygen? O2. Molar mass of oxygen, you know, that is 32 grams per mole. Molar mass of ozone, you know, is 48 grams per mole, right? Let's call this as V1. Let's call this as V2. Now, first thing. What is the volume of the entire gaseous mixture? That's 600 ml. If I ask you, how many total moles are there in the mixture? You will say total moles in the mixture will be equal to total volume of the mixture divided by what? 22400 ml, which comes out to be 6 upon 224. So these are basically the total moles present in the mixture, right? Which formula I used? Given volume divided by 22400, because the mixture is present at STP. My dear students, is there any other way with the help of which you can calculate total moles in the mixture? You know, the mass of the mixture is given to me as 1 gram. So I'll say total moles present in the mixture could have been calculated with the help of one more result as well. Mass of the mixture divided by average molar mass of the mixture, right? Mass of the mixture is 1 gram divided by MAV. This could have been one more result with the help of which you could have calculated the total moles present in the mixture, right? So first, I calculated the total moles present in the mixture with the help of volume result. Second, I calculated the total moles present in the mixture with the help of mass result. Now, both the things are giving us the same thing. Both these terms are giving me the same thing. What is that? Total moles present in the mixture. So I can directly equate these two. When I equate these two, I'll be getting 1 upon M average is equal to 6 upon 224. So from here, you can calculate M average. M average is nothing but 224 divided by 6. And units of M averages are grams per mole. So first thing, I calculated the average molar mass of the mixture. And I got to know average molar mass of the mixture is nothing but 224 divided by 6. Now, my dear students, since the mixture is present at STP, that means pressure temperature of the mixture is constant. If the pressure temperature of the mixture is constant, therefore, instead of M average, instead of MAV, I can just write M1 V1 plus M2 V2 divided by V1 plus V2. And as per the question, it is nothing but 224 by 6. What is M1? M1 is 32. What is V1? V1 is 600 minus X. What is M2? M2 is 48. What is V2? V2 is X. Divided by V1 plus V2 is nothing but 600. Is equal to 224 divided by 6. Just cross multiple the stuff and get the value of X from here. And the value of X, value of ozone from here, you can easily calculate by just cross multiplying things, right? And that's something which I was supposed to calculate. Is this particular question clear to you? We were supposed to calculate the volume of ozone in the mixture, correct? We were supposed to calculate the volume of ozone in the mixture. And you got to know exactly how do we do it. You got to know exactly how do we do it. Okay? Perfect. My dear students, mass of this entire mixture was 1 gram. Volume of this entire mixture was how much? It was 600 ml, right? Okay. So total moles present in the mixture will be given volume divided by 22400. Similarly, total moles present in the mixture is mass of mixture by average molar mass. So both the things are same basically. They are giving total moles. So I equated them, got the average molar mass. If you got the average molar mass, so average molar mass, instead of that, I wrote M1V1 plus M2V2 divided by V1 plus V2, right? Clear? So you know what? You could have solved the same question in one statement also. You could have solved. If your concept is strong enough, I mean, you could have solved the same question in one statement. Have a look how. Have a look how. For example, this was your container. The container was containing O2 and O3 gas. The mass of the entire mixture was 1 gram. The volume of the entire mixture was 600 ml, right? Let's assume out of 600 ml, there are X ml of ozone and this will be 600 minus X ml, right? This is something which we know. The entire mixture was present at STP. The entire mixture was present at STP, right? What is the mass of the entire mixture? The mass of entire mixture is 1 gram. That means the mass of O2 plus mass of O3. This value is equal to 1 gram. Agreed? Okay. Now, if I talk about O2, do you know volume of O2 in the mixture? Yes, you know volume of O2. How much is that? 600 minus 6. This is the volume of O2 in the mixture. If I divide this with 22400, if I divide with this with 22400, what do I get? I got the moles of O2 in the mixture. I got the moles of O2 in the mixture. If I multiply moles of O2 with the molar mass of O2, what do I get? This is the mass of O2 in the mixture. This is the mass of O2 in the mixture. Mass of O2 in the mixture is this term plus mass of O3 plus mass of O3. What is the volume of O3? X divided by 22400. What do I call this term as? Moles of O3. Now moles of O3 multiplied by molar mass of O3. What is the molar mass of O3? Molar mass of O3 is 48. So this term, this entire term, this term, I'll be calling it as mass of O3 in the mixture. Moles multiplied by molar mass, that gives me mass. And as per the given equation, that's 1. Correct? You got one equation over here, which contains one unknown, right? Solve this, get the value of X. This is one more way of solving the same question. Yeah? Is it clear, guys? Is it clear to every one of you? We can solve the same question in one line also. I hope both the concepts are absolutely clear to every one of you. Okay? So guys, I think we should stop with this. And in the next session, what we are going to do, in the next session, we are going to do stoichiometry, right? Next session is going to be equally important and next session will be day after tomorrow, right? What is today? It's Wednesday today. So Wednesday, Thursday, Friday. So Friday, I'll see you all at 7 p.m. Friday, I'll see you all at 7 p.m. with the concept of stoichiometry, right? I told you already I'll be completing this chapter in 4 sessions, guys. So I'm teaching every single thing in detail. I'm showing you all the problem patterns which can be asked, right? That's why it's going to take a lot of time to complete this chapter. Okay, perfect. So chalo, let's stop with this. I'll see you guys on Friday and do let me know in the comment section of this particular video whether you got the real feel of the mole concept, whether you got each and every concept of in over here, right? Do let me know all that stuff in the comment section, right? So that I'll get to know whether you are getting the concepts or not. So with this, I'm taking a leave. Take care. God bless you all and love you all, guys. Bye-bye.